Okay, in this video I'm going to continue on my tutorials on thermodynamics and statistical mechanics. This is video number 20 and we're going to continue our, we'll say our diversion from thermodynamics. I'm going to talk about the second video on the gamma function. So the gamma function is defined as you've seen before, and it generalizes the factorial to non-integers. So the purpose of this video is to do explicitly the integrals, which in the previous video I asked you just to accept. So look, if you want to watch this, it means you're looking to do the integrals explicitly. So for that reason, I'm going to do it reasonably quickly. Let's start with the integrals themselves. The first integral we had was the integral from 0 to infinity of minus x times e to the minus ax integrated dx. Now I'm going to assume that you're familiar with integration by parts. So in order to do integration by parts, we view u prime, v prime and v. Or this is the way I like to do it. So I'm going to select u as minus x. To differentiate that with respect to x, you get minus 1. I'm going to say that v prime is e to the minus ax, and integrate that, it's e to the minus ax over minus a. So integration by parts is uv minus the integral of v du. So if you do that, you're going to get that it's plus x e to the minus ax over a. You're going to get negative the integral from 0 to infinity of e to the minus ax over a integrated dx. Alright, so that's pretty straightforward. So I'm just going to let's just go ahead and do this. So we're going to get rid of this because the answer to that is pretty straightforward. You're going to get plus e to the minus ax over a squared. Now we're trying to evaluate the whole lot of this between 0 and infinity. Now a very important point here is that e to the minus ax as x goes to infinity goes to 0 very quickly, but x as x goes to infinity goes to infinity. But the point here is that e to the minus ax goes to 0 quicker than x goes to infinity, so that the product of x times e to the minus ax as x goes to infinity, it goes to 0. Alright? I'm sure you've seen that more than once in your mathematics courses. Alright? So that means that this integral here goes to 0 when we talk about infinity. So plug in infinity, we're going to get 0 plus 0, then we get minus, this goes to 0, again we get minus 1 over a squared. So the point is, the integral is equal to minus 1 over a squared. Let's look at the next integral. The next integral was plus x squared times that. So let's do the integral once again. Like I said, I'm going to do these pretty quickly because they're quite basic. So we're going to have u prime, v. So u is x squared. We have twice x for the derivative, e to the minus ax, and e to the minus ax over a. Next, if we just do the integral, or do the integral by parts, we're going to have minus x squared e to the minus ax over a plus twice over a times the integral from 0 to infinity of x times e to the minus ax dx. Note that this integral is the one we did just a moment ago. So we see we're getting some sort of recursion already, or a factorial as it turns out to be. So very quickly, I'm going to do this integral. So u prime, v prime, and v. So x1 e to the minus ax, e to the minus ax over minus a. So that means when we plug in all the things together, we're going to get minus x e to the minus ax over a. We're going to get x minus x e to the minus ax over a times the outside factor, which is 2 over a. And we're going to get plus 2 over a squared times the integral of e to the minus ax dx. Alright, so let's just do that integral, get rid of it here and plug in the integral straight away. And we're going to get, this will turn out to be a cube, and it'll be 2 over a cubed times e to the minus ax. Now of course, we need to evaluate this between 0 and infinity, like that. So I'm going to tell you, when you plug in all the answers, you're going to get 0, 0, 0, 0, 0, and the last one will be plus 2 times 1 over a cubed. So the point here is the answer is plus 2 times 1 over a cubed. So we can see that there is a pattern emerging whereby the next integral is the previous integral multiplied by some factor. And we know that in each one of the integrations by parts, the uv term goes to 0 because e to the minus ax goes to 0 quicker than x goes to infinity. Alright? So, I'm not going to do the rest of the integrals, so let's just write down what the integrals equal. I'm sure you can accept at this stage that they're all pretty straightforward. So if we write them down, we're going to get the following. Let's say take the first integral, minus x e to the, for now on it's going to say e to the, let's say e to the gamma, that's e to the minus ax, dx is equal to minus the integral of e to the gamma over a is equal to minus 1 over a squared. That was the first integral we saw. Now looking at the next one, we took plus x squared e to the gamma dx. That turned out to be 2 over a times the integral of x times e to the minus ax or e to the gamma dx, which turned out to be 2 times 1 over a cubed. Similarly, when we have minus x cubed e to the gamma dx, we got that equal to we would get is minus 3 over a times the integral of x squared e to the gamma dx is equal to minus 3 to 1 over a to the 4. And I'll add one more just for completeness. So minus x to the 4 e to the gamma dx is equal to plus 4 over a, the integral from 0 to infinity, x cubed e to the gamma dx is equal to plus 4, 3, 2, 1 over a to the 5. Alright, so what do we notice? We notice that, is that correct? Where's the, this should be x to the 5, or, let me think now, that should be plus, sorry, that should be plus, what am I doing here? So we note that the parity of the integral follows the parity of the factorial, minus, minus, plus, plus, okay? We see that the parity follows the whole way along. And that means that in general, if we wanted to get, let's say, if we wanted to get the integral of x to the 100, the plus to plus 100 e to the gamma, well, we know that the answer would be plus 100 factorial over a to the 101. Alright, we know that at this stage. That's pretty straightforward. So hopefully you can accept what the integrals are at this stage. And very quickly, just to show you our derivatives, like I said, I know I'm going pretty quickly, so let's take the integral, but this time we're going to take the dA of e to the gamma, integrated dx. Well, if you want to get that, that's pretty straightforward. That just turns out to be minus x times e to the gamma dx, which of course is that integral. So then if we get d2 dA, well, we're going to get, this will turn out to be a plus x squared, and it'll turn out to be the previous integral. Then if we get d3 dA cubed of e to the gamma, we're going to get minus here, this will turn out to be a cube as well. Because we're taking the derivative d dA of e to the minus ax is equal to minus x times e to the minus ax. Alright, like I said, I wanted to do that pretty quickly. I know it was very, very quick in fact. So thanks for watching. Please pass it on to your friends, subscribe to my channel, and if you're in a good mood, you might also click on an ad. Thank you.